Hi, questions in mechanics in this textbook. Problem 8.7. Using elementary Newtonian mechanics, find the period of a mass m1 in a circular orbit of radius r along a fixed mass m2. Using the separation into cm and the relative motions, find the corresponding period for the case that m2 is not fixed and the masses circle each other a constant distance r apart. Discuss the limit of this result if m2 goes to infinity. What would be the orbital period if the Earth were replaced by a star of mass equal to the solar mass in a circular orbit with the distance between the Sun and the star equal to the present Earth-Sun distance? Solution. Consider this case. We have this equation. Then we find this result. Now, consider this case. The Lagrangian is given by this one. And we have this expression. This gives this result. Then we find those equations. Then we find this result. Then we see this conclusion. Consider this case. We have this result. Consider this case. We have this result. Then we conclude this result. Problem 8.8. Two masses M1 and M2 move in a plane and interact by a potential energy. You are given by this one. Write down their Lagrangian in terms of the Cm and the relative positions, and find the equations of motion. Describe the motion and find the frequency of the relative motion. Solution. Express the Cm and the relative coordinates. We see this result. Then we find the equations of motion. We have this conclusion. Thanks for watching. Bye.